section 3.13, motion along a straight line. We're discussing about displacement, speed, velocity, acceleration, and how to distinguish between instantaneous velocity and average velocity. First question would be, look at the following diagrams, the diagrams below. Can we have a situation where when distance is positive and displacement is negative? So can we have this a situation when distance is a positive value and displacement is a negative value? As we can see on the diagram on the left, distance represents either path 1 or path 2 going from the house to the lake. Obviously, this is the path that we usually take in everyday life because there's rarely a straight road between one point and the other. And the displacement is the straight point between the straight line between the house and the lake. So you see the displacement here is 5.0 kilometers, and the path has a different value. They both have different values, much bigger than 5.0 kilometers, as you can see on the diagram. Here, the diagram on the right says that displacement at point A is 0. Although we can see that this person went up 3 meters from A to B, B to C, another 5 meters, C to D, 3 meters, and then D to A, another 5 meters. So the distance he traveled at point A is 3 plus 5 plus 3 plus 5, that means 16 meters. But still the displacement at point A is 0. The question again, look at the following diagrams. Can we have a situation when distance is positive and displacement is negative? If we look here, you drive from your house to the grocery store and then to your friend's house. You go from your house to the grocery store, and then you're going back to the friend's house, which is farther down the road from your home, and then we observe that the displacement is minus 2.1 miles, so it's 4.3 miles from the house to the grocery store, 4.3 miles back, and then another 2.1 miles to the friend's house. But the distance is 10.7 miles. That means we calculate 4 miles there, 4.3 back, another 2.1, maybe 10.7, but displacement is minus 2.1 because considering the point where I started, actually my final destination is not to my right, it's not to my positive axis, it's actually to the left, towards the negative axis. So I'm going minus 2.1 miles from my home to my friend's house. That's why on the previous diagram, the displacement at point A is 0, because practically I'm coming back where I started. So the difference between the initial and the final point is 0. There is no difference. I'm going back exactly to where I started from. So here on the right, we can have a definition of distance. Distance versus displacement. Distance is the total length of the path measured in meters. It's a scalar. Displacement is the same thing measured in meters, but it is a vector because the displacement calculates a change in position regardless of the path. So it just calculates the change in position from point 1 to A to point B. So that means the delta x calculates the final position minus the initial position, and that's what makes it a vector, because it can have positive values, it can also have negative values. That's why on our picture, the final position is minus the initial position gives me a negative value.